All right. Hello viewers. I'm here again. We have a question here before us, and this question says an object is acted upon by two forces, 5 Newton and 12 Newton. Calculate the resultant force if the two forces act at an angle of 40 degrees to each other. So here is the question. And how do we approach this? In my previous video, we had a similar case, but in the question, the angle of inclination between the two forces was 90 degrees. So, but this time the angle is what is 40. That is to say, the angle of inclination is what, less than 90 degrees. So the approach is different. When it is 90 degrees, we use Pythagoras principle, but now the angle of inclination is less than 90, and it means we are going to use a different thing. And here we are going to apply cosine rule to find the resultant, then sine rule to find the direction. All right, so let's go. So the solution, see my diagram here. This is my diagram here. I have, this is 5 Newton force. I denoted it to be P, then 12 Newton. I said let it be Q. You can see Q here. Okay, so I look at the angle of inclination given to us is angle 40, and here I draw a line to form the resultant force, and the resultant force R is given is here. I denoted this place R, which is the resultant force, and here we have beta here. Well, how do we get this? We are going to be looking at the angle of the resultant. That's the direction of the resultant force, and that direction is the beta. I denoted it to beta, to be beta. Then here we have 140. How come about 140? The 140 here is the supplement of the given angle. Supplement of the given angle is here, which is 140. All right, so let's go. Here R, which is the cosine rule, is equals to P squared plus Q squared plus Q squared. Can you see Q squared minus 2PQ cos alpha? Yes, the alpha here represents the supplement of the given angle 40. So substituting the values, we have 5 squared plus 12 squared minus 2 times 5 times 12 cos 140, which is a supplement of 40. Supplement of 40. Supplement is an angle that when added to a given angle we give 180. So if we add 140 to 40 degrees, which is a given angle, we are going to arrive at 180 degrees. So it's a supplement you use in this place. All right, so here we have this is equals to, this is 12 plus 144, that's 144, minus 2 times 60, minus 2 times 60, because 5 times 12 is already 60, then into minus 0.7660, cos 140 is minus 0.7660. So we have 169 plus 91.92. Okay, all right, so we have plus because minus here times, look at the minus times minus here, we're going to give plus. That's why we're having this. So here we have this plus this is going to give 260.92. so the square root of this is going to give us 16.2 Newton. So this is the resultant force. But as I said in the previous video, when you solve for the when you are solving for vectors, you have magnitude and direction. So there's need for us to find the direction of the force, the resultant force. So we now say, to find the direction, we are going to take the sine rule at this point, and we're going to say the R, which is the resultant force, all over angle Q. Look at the R here. We have our R here, all divided by this angle from your sine rule this divide by this length divide by this angle is equals to this vertical force here, this force here. Can you see it here? P. Can you see that P all divide by sine Q? Can you see that? Sorry, all divide by sine beta. Sorry about that. All divide by sine beta. And what is beta? Beta is this angle, which is the direction of the resultant force here. Can you see that? And that is what we are looking for. So here we have 16 all over sine 140 is equals to 5 all over sine beta. Remember, 5p is 5. That is why we're having 5 there. So with this, we can simplify this by cross multiplication. It's going to give us 16 sine beta is equals to 5 sine 144. So dividing both sides, or let's first of all take the 5 sine 144. Can you see 5 sine 144 here? Is going to give 3.2139 all divided by 16. That is by dividing both sides by 16 is going to give this. So that sine beta is going to give 0.2009, and beta is equal to sine inverse of 0.2009, and this beta is equal to 11.60. This is the direction of the resultant force. Thank you. Subscribe and share, like the video, and much more will be coming. The next question is, what if the angle of inclination is greater than 90? Remember, this part we did when it was less than it was 90, and now this particular one is less than 90. But what about the angle? What about when the angle of inclination is greater than 90? What do? We apply the same cosine rule. We apply cosine rule to find it. Is that okay? The same formula we use the same approach. You're going to arrive at the same as a correct answer. Thank you.